Again, just a note to our participants and our those folks presenting, we will be recording this for folks to watch later. So I would like to begin tonight by first thanking those of you who are here to come and learn about the goal that we have, and that is to help share information about COVID-19. And our goal tonight is to really share information, the latest information about helping to control the spread of COVID-19. We do have interpretation. If we have any Spanish speakers here, you can go down to your interpretation button and select Spanish. On the bottom right-hand corner, it says interpretation. So as part of our community of practice, we want to make sure that folks know they can also participate in Spanish. And our interpreter tonight will be Giovanna Cook, assisted some by Irma de Preto. If we see her coming back, I'll have to find her. I'm sorry, it looks like I haven't seen her yet make it back in. I want to start tonight by introducing David Wise, Vice President of Marketing, Advancement, and External Relations.
Thank you, Mel. Good evening, everyone, and thank you for being here this evening. Before we begin, we would like to make a short video presentation. This 3-minute segment was originally crafted for the introduction to this year's virtual Bounty of the Valley Scholarship Dinner. And upon reflection, we decided it did such a wonderful job of reminding us of the beautiful place that we inhabit in the world on the homelands of the Yakima Nation, a place we're all so anxious and eager to get back to as a community. So Mel, if you would please start the video. Well, we appear to be having some audio video difficulties. Is it running on your end?
Yeah, I hear it on my side. Is it working for you, or did it not come through? You can check again. I apologize. Thank you, Christina. See you there.
For time immemorial, the Yakima people have inhabited these fertile lands. The bountiful river, indigenous plants, berries, and roots, and vast wildlife have provided for our people, and we lived in harmony with nature. Mother Earth has provided from the beginning of time, but Mother Earth does not stand still. It moves about the sun and around its axis every day. She's just a little changed. And so too is that little portion of the earth we call home. As new peoples discovered this fertile place, with them came different ways of life. Agriculture that would take root in the fertile soil would thrive and grow. The melting snows from Pato and its sisters, providing the water that transformed these dry lands into America's fruit bowl, land that now feeds the world. With agriculture came industry, and with industry, the need for education. But the Yakima Valley lacked sufficient educational opportunities. 3 women, keenly aware of the untapped potential of the women and men of the valley, said enough is enough and set about to correct a great wrong. Starting a college? You must be crazy, said most. Just tell me one thing we can't do, retorted Martha Yallop. The doubters only fueled their resolve. Martha, along with Violet Lumley Rao, both Yakima tribal members, and Sister Kathleen Ross, a recent arrival to the valley from the Sisters of the Holy Names of Jesus and Mary in Spokane, were determined. The people here were as capable as any from Bellevue to Boston. The only thing they lacked was the opportunity. And what's more, the people here had something the others did not. They wanted it more. The three appeared before the Yakima Tribal Council to present their idea and solicit their guidance as to what the college should be. It was, after all, going to be located on the Yakima Reservation. Should it be a tribal college? The council deliberated the plan and whom it should serve. The council, thoughtful and wise, aware that Mother Earth was constantly in motion, proclaimed that this college should not be for one people, but for all people, and Heritage College was born. Now, nearly 40 years later, and with more than 10,000 graduates, it has proven to be as fertile and bountiful as the surrounding land. The teachers, nurses, social workers, scientists, and business leaders it has educated, as devoted to this place we call home, as were the countless generations that preceded them.
Every time I see that video, I'm reminded of what a special place we all inhabit and why we inhabit it, and the great and amazing work that we are a part of. It is now my honor to introduce you to the first of our two panelists this evening, Dr. Christina Nyirati, Chair of the Nursing Department. Christina is a second-generation Eastern European American. She uses the pronouns she and her. She is deeply devoted to all student learning at Heritage University and seeks to build a community of physical, intellectual, and spiritual safety for our community of learners. She has worked collaboratively to create a nursing program at Heritage that is responsive to the needs of our diverse community, to correct inequities that threaten the health and well-being of the families and community that have raised our children. She is also a co-facilitator in the overdue reckoning on racism in nursing. Mel, if you would now please introduce Dr. Cao.
Yes, I'm very excited to have the honor to introduce Dr. Bob Cao. Dr. Bob Cao is a second-generation Taiwanese American and uses pronouns he and him, they and them. Dr. Cao is deeply committed to student success in biology and health sciences pathway, as well as genetics, genomics, epigenetics, and does workshops for Bachelor's of Nursing students at Heritage University on these topics. Dr. Cao is also a leadership fellow in the nationally recognized Partnership for the Undergraduates Life Science Education. Beyond that, he is one of the most compassionate and caring instructors we have at Heritage University. And it's my honor to be able to be here with both of our distinguished guests tonight. Thank you. Bob, I'm going to turn it over to you and Christina to start the presentation.
Thank you, Dr. Hill, for the kind introduction. And I'm happy to work alongside with our colleagues, also with our colleague, Dr. Nyirati. And we have our first slide for our Heritage University community. Dr. Nyirati.
Thank you, David, for your kind introduction. And Melissa Hill, you gave us a nice introduction to how come we care about our whole community. We want to feature tonight how we protect our community. We protect our individuals on our community, the community itself, our students, their families, all of our staff and faculty. And I'm an old public health nurse by trade, and we actually are going to be talking about how we use principles of public health to protect our community. This will be very useful as Dr. Gao goes on later to explain some of the intricacies of the different methods of protection that we use. So let's go ahead and talk about our epidemiological triangle. Oh, before we do that, here's another slide that explains how serious the problem has been to date. This is the state of Washington. And if you look at the different shades of blue, the lightest shades of blue show us where there has been the least COVID, up into the darkest shades of blue, where there has been the most COVID. And the deaths have been proportional to these numbers of cases. These cases began being counted in February. If you look here at the Yakima County, which is in central South Washington, this is where we are. We'll have a slide later on that actually shows us the current vulnerability, the danger that we still are in Yakima County. Can you please give the next slide? This is a very simple epidemiologic model. It's a triangle, and it is the most basic model of how disease is transmitted. In order for there to be any kind of sickness, there has to be from infection, like the COVID SARS-2 virus, there has to be a host. At the top of the triangle is the host. Over here in the lower right hand of the triangle, there is the environment. And over on the left-hand side of the triangle, we have the agent. Now we're going to keep filling this triangle in a little bit to make it more specific all the time to SARS, to COVID. Please go to the next slide. So here we go. The host is the organism that harbors the disease. Down to the right-hand corner, we have the environment, which includes all those external factors that cause or allow disease to be transmitted. If we go over to the left now, we have the agent, which is the actual bacteria or the virus that cause infection. Let's go to the next slide, which is more filled in. So here we have at the top of the triangle again, the host. The host in this case of the SARS-CoV-2 virus is a human being or human beings. Go over to the right lower corner of the triangle, we have the environment. And in the case of SARS-CoV-2 virus, it is the air carrying the virus or the respiratory droplets that carry the virus, and also close contact between one person to another. That is the environment in which the SARS-CoV-2 virus is transmitted. And then over to the left lower hand corner of the triangle, we have the agent. In this case, it is actually the SARS-CoV-2 virus itself, the organism itself, which causes severe acute respiratory syndrome, coronavirus 2. Next, we're going to come back to these concepts later on as we talk about how we interrupt. You see the sides of the triangle. Anytime we can break any of those sides, we can interrupt the spread of this devastating disease. And so we're going to talk about it later on as we get into this better. For now, I want you to pay attention to the lower left-hand corner, which is the agent. And Dr. Bob Gao is going to actually feature the agent. He is going to show you a picture of the SARS-CoV-2 virus, which is a spike protein. So this is an electron microscope picture of the agent. Go ahead, Dr. Gao.
Thank you, Dr. Nyirati, for sharing the importance of the epidemiological model triangle. And as Dr. Nyirati mentioned, here is a electron microscope image of the surface of the SARS-CoV-2 virus. And decorated around the surface, you can see the spike protein of SARS-CoV-2. And in a moment, this will become important because in the next few slides in the animation, we will be illustrating how the virus is able to enter into the host cell. So now if we take the next slide here, so here is example, again, in this animation is the spike protein that we had seen earlier. And this special protein called the spike protein is right at the surface of the SARS-CoV-2 virus. And this is important because it will then interact, or in other words, has a special type of molecular glue, where the spike protein of SARS-CoV-2, shown here in purple, then attaches to a special host, another protein that's found at the surface of host cells. This is what we call a special protein. We call this a receptor, or ACE2. This molecular interaction between the spike protein as well as the host receptor, ACE2, is important because this molecular sticky glue attachment between the spike protein as well as the host cell receptor, ACE2, allows this viral entry into the host cell. And so this molecular animation illustrates, again, how the virus enters into the host cell. And I think in the next slide, I think before we get to the symptoms of COVID-19, I'm going to briefly pause the screen here and kind of just illustrate this here as so you can think of this, the SARS spike protein I'm kind of holding here is like a molecular Velcro here, not shown to scale. And to my right-hand side here is the receptor in this pipe cleaner. So this molecular attachment is like a molecular sticky glue that then allows, once these interact, then allow the virus to enter into the host cell. So in a moment, I'm going to now come back to the share screen here. And in the next slide, our colleague, Dr. Nyirati, will talk more about the symptoms of COVID-19.
You're muted, Dr. Nyirati.
If you will think about that picture of the COVID virus with the animation of how the sticky spikes of the protein begin to stick into the human person, this is how this happens. The person breathes the respiratory droplets or the air that contain the ACE2, that contain the virus. And in the lung are these receptors. They are ACE2 receptors. And so that sticky glue that is on the end of the virus just gets in there and sticks to it. And what happens is that within 24 hours, hundreds and thousands of those those viruses make copies of themselves. They really make copies. It would be just like you would go to a copy machine and make copy after copy after copy after copy. And what happens is that the lungs become inflamed with disease, because right away the body recognizes that this is a disease and it makes different things go to that place. It makes white blood cells go there. It makes there be dilation of the blood vessels. And the body is trying to destroy this virus. But in the process of destroying it, the tissue of the lungs becomes damaged. As a matter of fact, if somebody were to take an X-ray of what the lungs look like after 3 to 4 days of many, many copies of this virus being spread all over the lungs, the tissue of the lungs looks very, very damaged. It looks actually like broken glass. And this is why people can't breathe, because there's so much destruction of the tissue of the lungs that the lungs can't do their job anymore. So there can be damage to the lungs. Here's the issue that happens with the COVID. People think that they get sick with the COVID and then the lungs heal and then it's over. When in fact, the lungs are never quite the same after that, especially in someone who has a very severe infection. Also, there can be stroke, embolisms, which means different types of moving blood clots from one part of the body to the next, or blood clots that are right there. So we do know that there is a very strong likelihood, if people get the virus, that they can have serious blood clots. Later on in our presentation, we will talk about some of the vaccines that can also cause stroke and blood clot. However, the amount of stroke and blood clot that have occurred because of having COVID is many, 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 many more people have had serious blood clotting problems from COVID than they have had from any kind of a vaccine. Also, there can be very serious inflammation of the heart muscle. This can be in people of any age, but all of these symptoms occur mostly in persons older than 50. We are fortunate that most of the students on our campus are younger than 50. If they get the virus, they can transmit it to people in their families who are older than 50. And we do consider the families of our students as part of our community. Also, it can impact younger persons who have weakened immune systems. At Heritage University, we have students who have weakened immune systems. We have students who have type 1 diabetes. And that does cause a change in the immune system. Pregnancy also causes the immune system to not be all jazzed up. And that's because if it were all jazzed up, there would be an increased risk of women rejecting their babies when they're pregnant. So pregnancy is another thing that can cause weakened immune system. We also have students who have gone through chemotherapy. That's medication that has been given to them, or for cancer. And we also have students who have undergone radiation therapy for cancer. There are some things that cause permanent changes in the immune system. So we have to make sure that we understand this, that those people are at risk. Young persons who are not very sick with the virus, who contract it, can transmit the virus to persons who are at risk for long-term effects. So we know that our student population are in an age group that is at least risk for having complications of COVID. They are just as likely as people over 50 to contract the virus. but they have less risk of having long-term impact, but they can transmit it to people who are in high-risk groups, including people over 50 and other young people who have immune compromised systems. We can go to the next slide. These are the symptoms of COVID-19, and these can happen in varying degrees of severity. So fever or chills, cough, shortness of breath or difficulty breathing, that comes from the spikes of the virus attacking the lungs, fatigue, and fatigue happens because the entire human system is working really, really hard to overcome this serious virus. And the work is as hard as going out and mowing the lawn all day long and then running around the block many, many times, many miles. You know, it's hard work that the body's doing. Muscle or body aches that happen because of just general inflammation. The whole body becomes inflamed. Headache, new loss of taste or new loss of smell. We will talk in a little while about the new variant, which is the Delta variant. There seems to be less problems with loss of taste and loss of smell than the original COVID SARS. But it is much more damaging to the lungs. Sore throat, runny nose and congestion, nausea and vomiting, and diarrhea. Those are all common symptoms of COVID-19. Please go to the next slide. I'm going to start talking about this, and then I am going to probably defer to Dr. Gao's scientific explanations in terms of what we know. I'm very interested in this as a public health nurse. I read the epidemiologic literature every morning that comes to my desk that I subscribe to. So as of today, June 29th, 2021, the new variant, which is the Delta variant, accounts now for 10% of the country's COVID cases. This is a variant that did not exist 6 months ago. This is a new variant. It now is the most dominant strain of the new strains. There are many new strains. And the Delta variant is not yet reported in Yakima County. There is risk of more severe illness, and it is more easily transmitted. It mostly is affecting unvaccinated individuals. It appears as though people who have been vaccinated against the original COVID variants do have protection against the Delta variant. It does cause loss of smell, but more headaches. Like the main strains of the coronavirus, it destroys the lungs, just lung tissue, and it can kill unpredictably. And it's much more easily to transmit, and it causes more illness and more death. Vaccines authorized for use in the United States appear to provide protection against the Delta variant. Please go to the next slide. I want Dr. Gao.
Yes.
Could you please explain just for a moment how come there is like an evolution of the virus, you know, that viruses they fight to live. Can you explain that a little bit? Why is this happening? Why is there this a mutation that has happened?
Yeah, thank you, Dr. Nyirati, again for sharing the COVID-19 symptoms. And you're asking a very important question. Why do we see these molecular changes or mutations, or in other words, different variants, right? In this case, now we're going to use the Delta variant. And this comes back to the virus. It has its own life cycle. And over time and space, when it, as we talked a little bit earlier, when it attaches to molecular sticky glue and enters into the host cell, it then makes many, many, many copies, as Dr. Nyirati mentioned. As it's making many copies, there will be some, it could be one or two molecular changes that are occurring. And this will then continue on as the virus then breaks through and then makes over hundreds and millions of copies to infect and spread through air droplets or airborne and infects the next person. So as it spreads throughout the world, it goes through, it comes back to the life cycle and can change the changes in the DNA, or I should say the RNA in this case. This is an RNA virus, and allows the virus to continue to spread and thrive.
And the comment I would like to make about what Dr. Gao just said is this: the longer the virus is able to continue being transmitted, and the more people that it is transmitted to, the longer time that the virus will have to mutate into sometimes less serious viruses. But right now we have one that is very serious. And the length of time that, there is some belief among the scientists who are epidemiologists, if we could only get to a certain percentage of the population who is vulnerable for getting the virus, that we could maybe stop the mutation, because the virus has more of a chance to mutate the more time it has to live in our community. Did that make sense, Dr. Bob?
Yes, thank you for sharing that, Dr. Nyirati. Yes, yeah.
Thank you. So I'm going to defer to you now, Dr. Gao.
So as our colleague, Dr. Nyirati mentioned, we were discussing about the Delta variant and how the vaccines, you might have heard it in news, one of which is called this mRNA vaccine. And in the next few slides, we'll talk more about, again, how these vaccines work. And then our colleague, Dr. Nyirati, will talk about more in a moment of the clinical dimensions related to the vaccines. And so here, I'm going to take a closer look here. And here is, so I'm going to kind of walk through a little bit step by step. So how the mRNA vaccines work. And you might have heard in the news, these two vaccines are the one by Mrna, as well as the Pfizer. These are so-called mRNA vaccines. Now, the reason why this is important is, remember we talked earlier about the spike protein, right? So what happens is, and the reason why this is important is vaccines help our immune system so it can recognize the spike protein and then develop what we call antibodies that will then help fight off the infection very efficiently. So the very first step is the step is it uses what we call a messenger RNA or mRNA, and this is a distant cousin to the DNA. This is a special RNA-based sequence, and it will provide the instructions to then produce only the spike protein of SARS-CoV-2. And then what happens next is in this vaccine, again, there's this special type of coating that surrounds the messenger RNA. So it's packaged almost like molecular snail mail. And this is what consists of what's found in the Pfizer as well as the Mrna vaccines. And then this final last step here is once given to the individual, what will happen again is this vaccine again does not contain any virus. Again, this is only the messenger RNA that encodes the spike protein, and it does not change our DNA, host DNA at all. Okay. So once the RNA is delivered into the cell, it then comes to this last step I was mentioning a little bit earlier, and it helps to provide information to our immune system. There are B cells or bone marrow cells derived from the bone marrow and produce antibodies that will recognize the spike protein. And this will then become very important, as Dr. Nyirati will mention, about what it means to be fully vaccinated. And we'll talk more about that in a few slides from now. Another important information is that from ranging from individual to individual, there might be some mild fever or headache or chills, but in the first 24, 48 hours, this is completely normal, and it's a sign that the vaccine is working. Okay. So that's the example here on the mRNA vaccine.
I just want to emphasize something that you told us. And this might be a question that comes up. And if you want to ask it again, anyone who's in the audience, it is really important to understand that when you get the mRNA vaccine, which is either the Pfizer or the Mrna, you are not getting the virus. You are only getting the messenger RNA that's wrapped up in a coat that sends information. It is not the virus. So it doesn't give you the virus. Some people think that it gives them the virus because there are some symptoms that people get, such as they might have a fever, a headache, or chills. And these are also some of the symptoms of the virus. And therefore, people get very frightened that maybe they have gotten a shot, a vaccine that has caused them to have the illness itself. So I hope that that commentary helps.
Yes, yeah, thank you, Dr. Nyirati, for mentioning. Yeah, that's very important. And so in the next few slides, we'll talk a little bit about another type of vaccine that is also effective against the Delta variant. And this specific type of vaccine is what we call is a viral vector vaccine. Again, after we kind of go through the key steps in a moment, Dr. Nyirati will then share with us the different COVID-19 vaccines, as well as the important clinical dimensions of this. So we're going to take a closer view here. And again, I'm going to also mention here that you can think of this as another pathway, again, that can help protect against the Delta variant. This, what we mean by a viral vector vaccine is that in this case, instead of using the RNA molecule as mentioning, it uses its distant cousin, the DNA. And this double-stranded DNA that's again wrapped, that will only encode the spike protein. This is what we call a vector. So it's almost like a molecular sandwich, only the DNA that encodes the spike protein virus that is wrapped around and delivered. We call this is the vector. Okay. And Again, as was mentioned earlier, this vector and examples of these that Dr. Nyirati will talk more about in a moment includes the J&J Janssen. Another example is the AstraZeneca vaccine. Again, these are all effective against the Delta variant. What I want to also emphasize, as Dr. Nyirati had mentioned, is that the vaccine, again, does not contain the virus that causes COVID-19. And it cannot give you the COVID-19 symptoms. So just want to reemphasize the important point that this vaccine does not change our genomic DNA in the host. The key takeaway message is it produces, tells our immune system, specifically the B cells or bone marrow cells, to produce the antibody that will recognize only the spike protein. And this is important because, as Dr. Nyirati will mention a little bit later, this will help, once we're fully vaccinated, help us to effectively counteract the Delta variant, as an example. And as mentioned a little bit earlier, there are symptoms, again, when our body responds to the vaccine. There could be some headaches or muscle pain. But again, these are normal signs that the vaccine is working. So now our colleague Dr. Nyirati will now mention more about the different types of COVID-19 vaccines.
Currently in the United States, there are 3 types of vaccines that are available. I want to tell you that none of these vaccines yet has had full FDA approval. These 3 vaccines have been given emergency use approval. The reason that they were given emergency use approval is because the rates of transmission of the virus and the numbers of deaths were so high that they did not go through a full, what we call a prospective clinical trial that medications usually go through. But they have been approved for emergency use. As they have been approved for emergency use, the FDA and the CDC, the Food and Drug Administration, and the Centers for Disease Control have been very careful to collect as much information as possible about the bad and good effects of these viruses. First, we have the Pfizer Bionic vaccine. And who can get this vaccine? You can get it if you are 12 or older. You can get 2 shots that are given at least 3 weeks or 21 days apart, or 2 weeks, and then you are fully vaccinated 2 weeks after your second shot. So 2 weeks after your second shot, you're fully vaccinated. I'm sorry for the mistake on this slide. It should say 2 shots 3 weeks apart. That gives enough time for this type of vaccine to teach the body how to create antibodies against the virus. There are people who say that they do not have any kind of reaction after the first shot, but they do after the second shot. And that's because the body now is able to see if there are any abnormal, foreign things that have come into the body. And this is something that is foreign, but it is teaching the body how to fight this foreign body. And as a result, people often have more symptoms after the second shot. The Mrna is now, you can get it if you are 18 years and older, and it's 2 shots given 4 weeks apart. I happen to have been vaccinated with the Mrna, and I was real happy because 2 weeks after I got my second shot, I was able to see my 29-year-old daughter for the first time in over a year because she got her Moderna too. So it was really wonderful. And then the Johnson & Johnson's, Janssen, people 18 years and older, it is one shot only, and you are protected 2 weeks after you get your shot. Let's go to the next slide. So here are the common side effects. On the arm where you get the shot, you might have pain, redness, swelling. Throughout the rest of your body, you could have tiredness. Go on to the other column there. Headache, muscle pain, chills, fever, nausea. Here's something that you should take under consideration. These are the common mild side effects. These are not the bad things that can happen. And there are some bad things that could possibly happen. Okay. But if you have had a severe or immediate allergic reaction after you get your first dose of an mRNA COVID vaccine, you should not get a second dose of either of those two mRNA COVID vaccines. And Dr. Gao, why don't you refresh us? Which are the two that are the mRNAs?
Yeah, so thank you, Dr. Nyirati, for mentioning. So as a reminder, the two mRNA vaccines are one, the Pfizer, and the second is the Moderna vaccine.
Mm-hmm. Please go to the next slide. So in summary, we believe that we care about each individual on our campus. We also believe in protecting not only our students, but their families and our entire HU community using these principles of public health. We talked about the SARS-CoV-2 spike protein and what happens that makes it invade the body and how it invades the body and the lungs and causes symptoms of COVID-19. And we talked about the different types of vaccines and the common side effects. So at this time, Dr. Gao, unless you have anything else you want to add to that summary, I am going to give this forum back over to Melissa Hill. Okay.
Yeah, thank you. We have extended, this is very in-depth information. And at times I know I personally have been challenged to really, I think, digest the complexity of, science is not my field of study. And so as a social scientist, I really have had to rely on my colleagues in other fields to really understand the uniqueness of viruses and how they work and mutate. And I feel like I'm ready for my first class, my first pathology class in epidemiology. I feel like, give me the test, let's get into it, because I feel as if I've been really living all of this vast amount of information. I also want to take a minute to acknowledge that this is scary. This has been scary from the moment we shut our doors and heard about things and watched the news and media. So anytime that things are new, this is my first pandemic. I have not experienced a pandemic before. But anytime that things are new and challenge us in a collective that was not something we asked for, right? This is something that happened to us. We're all on this journey together, whether we like it or not. And so I think it's important to take an opportunity to say, what are the things that we need to really understand? And that's why we invited Dr. Cowan and Dr. Nyirati here. So we do have some questions, and I want to give people a chance to ask additional questions either in the chat. Would someone on the panel please comment on the current information regarding length of immunity for each type of vaccine. So we know that there's 3. Could you talk a little bit about the length of immunity?
Dr. Gao, do you want to start saying something about that and I can follow up?
Yes, thank you, Dr. Hill and Dr. Nyirati. What I'm hearing is, so the question is, what is the current or latest information regarding the length of immunity for each type of the vaccine? And so I'll kind of circle back. We've talked about the mRNA vaccines, the Mrna and Pfizer. Now, in terms of length of immunity, and I think Dr. Nyirati can comment a little bit more about this. What I'm hearing is that I think there's still a lot of research into it to monitor the production of the antibodies that are produced. And so the exact length of the immunity, whether that this be in a year or if it's several years, again, I think there's continuous monitoring of that process. And then for the J&J Janssen or the AstraZeneca, again, I think this is, in terms of the length of the immunity, it's still being closely monitored in terms of the antibodies that are being produced and how long these antibodies then persist. But I think this requires continuous, observations as time unfolds. Dr. Nyirati?
Yes. Here's something for you to understand. Even though we've had SARS-CoV-2 with us for only 18 months prevalent, there have been other SARS types of infections for a long time. And scientists have been trying to work on immunizations, for about 40 years. And they've only, until now, been able to test immunity after vaccination in laboratory animals. This is really the first time that we've been able to observe what could happen in humans. Based upon what we know now, because we started giving the COVID vaccine 6 months ago, we have conclusive data that it protects people for at least 6 months. And there is good evidence that it will protect people for about 2 to 3 years. Whether or not people will need a booster shot or not, we don't know yet. It is a lot like the research that has to be ongoing. Every day people go to a lab to study the flu vaccine. What is that going to do? How is it mutating and how is it going to change from year to year? So as far as we know right now, we think that it probably is going to be effective for the next 2 to 3 years. We know that it's effective for at least 6 months because new cases of the disease in people who were vaccinated 6 months ago are very, 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 very low, if at all.
Thank you, Christina. Another question that's come in. Are there any methods to screen out individuals that will potentially be affected by blood clots and heart inflammation from the vaccine?
I would like to begin by saying something about this. The possibility of blood clots and heart inflammation, these are two very serious, potentially very serious problems. Whether or not a certain person is more likely to get it than another person, I don't know. So I have a daughter who is 29, and she and her best friend were talking to me about this on the phone just the other night. And they said to me, how in her good friend's name is Julie. She said, can Julie, how can we find out if she is going to be more effective than I am? What about my immune system? Is it stronger than hers? It's weaker? Is it possible that I could have an autoimmune disease that could make me have a blood clot, or that could make my heart have inflammation? This is a very difficult thing to think about and talk about. There are some genetic types of tests that we could do possibly for every person in the whole United States to discover whether they would be at more risk than other people. To do that would be very, very, very expensive. It would probably break our whole healthcare system. And so there is no practical way to know. And so that is why it is important for everyone to understand. Just like if you ever go get a procedure done, there are risks to everything, and then there are benefits. You have the right to understand what the potential risks are. Many of our students, the majority of our students who come to Heritage are women who are childbearing age women. The risk of blood clots is greater in those women than in women who are 50 and older, and greater than in younger children. The epidemiologic data shows that the risks are very, very, very low. But no one is free of that risk if you are a young childbearing age woman. So when you make the decision, there is a possibility, a very, very outside possibility. It's not very common, but there is a possibility that something really terrible could happen to you. And the best advice that I can give you as a nurse practitioner myself, is to have a serious conversation with your healthcare provider. Someone that you trust, someone who knows you and who can help you make that decision. I don't know, Dr. Gao, Dr. Hill, David Wise, do you want to say anything else about what I just said?
I'll just briefly acknowledge, I think that this, and I did type it to all of the panelists and attendees, we recognize this is a very personal decision, and I certainly am sensitive to the fact that when I read the research around and what had transpired with the I think it was 3 or 4 women who received the vaccine and had a terrible reaction to it. And so as I research these things, I certainly can appreciate and empathize and question, how do we know these are safe? And so I think what I appreciate about this conversation is that we have to recognize that we are still, and you mentioned this, Dr. Nyirati, that we are still in emergency authorization, and we know that there are still trials. And when you talk about the risk and consequences and things that we have a right to know for our individual well-being, we as an administration and as a community at Heritage, we had to balance those risks as well with our decision to open and how we open safely, and some of those same decisions that we made for our community. And I think that's, for me, where I have felt it was important to make sure that we knew and studied what was out there, and really took time to read and listen and understand, because that same there are going to be risks associated doesn't apply just to individuals, but I also believe it applies to what we do as a community together.
There's a question that Giovanna has put. Dr. Hill, would you read that question?
Yeah, so we have a question here, and again, anyone can post these questions. You can post them anonymously if you would like. what would be a simple and positive approach to persuade individuals to get fully vaccinated in our community, but are hesitant or resistant to get vaccinated due to misinformation about vaccines overall? And I don't think we have talked about the misinformation out there. And I think that is an important conversation that we have to address, right? Is what, there's so much information, and how do we know what's reliable, what's not? And we would appreciate kind of a maybe response to both of those.
Well, this is a question that is a lot like questions that I have faced as a public health nurse and as a nurse practitioner, all of my life as taking care of people. The thing that really hurts individuals a lot is fear and the uncertainty that they feel about what can hurt them. And so the question is, what would be a simple and positive approach to pursue individuals to get fully vaccinated in our community but are hesitant? Probably the most important approach is for people to have a trusting relationship with someone who is knowledgeable and who loves them. That could be, that's why I said it could be your health provider. It could be someone who's been taking care of you since you were an infant. Many of our students have been going to the farm workers clinic since a week after they were born and have a very close relationship with their providers. This is a very personal thing. The unfortunate thing is that the issue of COVID over the past 18 months has become used as a weapon, a political weapon that people use without considering what the real life experiences are of the people who are grappling with serious illness in their families, their own fears of being sick themselves, their own vulnerabilities to hearing information that just isn't true. So I have been keeping a little journal over the past 18 months of things. I've been writing it down in my journal of things that I hear, and things like there are people who have spread things that just aren't true. Like, more people have died from getting the vaccine than from COVID, which is not true. And that's just one example of that creates more fear. And so the best way to approach people is with love and knowledge and belief that each person wants, sometimes people have a tendency to dismiss people as being crackpots or buying into theories that are stupid. But these are all our brothers and sisters who are afraid for good reason. Something has really threatened the way that they think and feel. So the best way is to listen, to be supportive, give as much information as possible, and to continue caring. That's my approach. But Melissa Hill, why don't you talk? As a person who is the VP for Student Affairs, who cares about the hearts and souls and physical health of all of our students at all times.
Yeah, we've got, we do have one other, we have another question. I think this is really a relevant, an important topic that we're addressing. And so let's see what our next question is here, because I think this is going to wrap into it. So right here, the question we have is, how will HU keep vaccinated students safe from unvaccinated students? And this is part of that this is part of that challenge that we faced as administration when we went into the decision-making process. And so the first thing we grappled with was our mission and how do we make sure that we fulfill our mission. And we really wholeheartedly believed we need to find a way to open campus so that students can come and feel safe. And we felt that the most responsible thing to do with that decision was to require the vaccination. Now, there are 3 exemptions that we have offered. So those are out there for individuals to exercise, 2 of which are protected by federal law, and that is a medical exemption and also a religious exemption. And then a third that we offered for students, staff, faculty to be able to exercise around extenuating circumstances. And that's just because we want to be able to have that flexibility for our students and employees. And so that's very important to us, that we want to be able to give individuals that right to be able to exercise that. The other, very specific to the point of how do we keep people safe, I'm just going to go very quickly into some of the procedures that we've implemented. But I want you to know before I do that, these decisions were made in a collaborative, collective environment. I can't tell you how many articles Dr. Cow sent me that I did not understand, and I studied them and read through the methodology and then jumped down to the conclusion where they made a little bit more sense. I can't tell you how many people shared things one way or the other with me. And every single time I took that piece of information and I absorbed it and I appreciated it and I took the time to understand it, because I truly believe that this is a very personal decision, right? And we have to make a decision for our community, and I'll keep going back to that. But on campus, very specifically to the how will we help keep vaccinated students safe from the students that can't be vaccinated or choose not to be vaccinated or have an exemption approved. And remember, there are some people that will have medical exemptions. Not everyone can be vaccinated for different reasons. And so we need to be sensitive to that. And that's really the community and the population that we want to protect, right? So we will wear masks indoors. When we are indoors, we'll wear masks. When we go in to eat, we're going to limit the number of people. We're not going to be huddled around a table. We're going to monitor our ability to social distance. We're going to strive to make sure that we have 3 feet between students and staff as we're teaching. We're going to give people face shields if they cannot physically wear a mask, because I've had people reach out to me who have asthma and don't feel comfortable wearing a mask. We're going to have people that do extensive disinfecting on a regular basis. And then we'll also, I shouldn't say we will, we already have made these improvements within our ventilation system to increase the air circulation. So those are some of the things that we'll continue to do. David, am I missing anything?
I think that's primarily it. What we're hoping for is that, of course, the bulk of the people on campus are vaccinated, and thereby we minimize the chance for spread of the disease. And then we will employ all of those tactics that you just stated, Mel, to make sure that we continue to be safe. Safe social distance, cleaning regularly, wearing masks indoors. And so we're hopeful that we can nip this in the bud and keep any cases from being contracted on campus.
And thank you for reminding me too, we will have the hand sanitizers. You know, those were not common things that we had in our spaces before COVID. And so, you know, we're also going to take some internal measures where if we have large meetings, we may decide to have those meetings, you know, via Zoom. We have now mastered these new technologies in a very short time, and we've implemented them. And so some of these will stick around, and it also increases our ability to have access. So I want to thank our participants. We have a comment. I just want to share the comment. The vaccine is very new, and we are all still under state of emergency. It's a difficult choice and very personal. However, I do believe that the safety of my family and my colleagues is important. So I just want to thank you for that comment. I would like to offer up, if we don't have any additional questions. However, if individuals have questions about our Safe Open plan, or if individuals have questions that they would like to ask personally and would like to consult, we certainly will do our best. We can't do that for 700 students, but we will certainly do our best to make sure that we are providing everyone with as much information as possible. Dr. Nyirati and Dr. Cow have put together resources and links, which we will make available along with this webinar, so that you can go back and share it with your family members or other individuals, and make it a point of reference for people that still have questions. So before we conclude our session, if there are any last minute pressing questions, please feel free to send them to us in the chat, or write them in the Q&A. If you want to send them anonymously, you can do that. I'll give folks a chance to do that. I also want to just share and take this opportunity while people might be thinking of questions to recognize that our guest here today, Dr. Nyirati, I don't even venture to guess how many years you've been doing community health, but this is her life work. I don't think there is anything that is more important to her than the health and well-being of a community. And that community involves lots of individuals, no matter where they're at in the decision-making process. And I want to recognize and thank you for your compassion in this process. For Dr. Cow, I don't know a smarter man who also plays a musical instrument beautifully in our cafe. But the time and the care which you have taken to help us understand the science behind this and the complexity, for those of us like myself, where it does not come naturally, the scientific methodology does not come naturally in the understanding these things that we can't see but that affect us. And so this whole microscopic world that has invaded our lives and our spaces and completely turned our world upside down is not visible. You have made this understandable, and I just want to thank you for your knowledge and your compassion in all that you've done. So we really appreciate your time as well. All right, friends. Well, thank you very much. I don't see any other hands up or any other things coming in, so we will go ahead and log off now. And again, just really want to take the opportunity to appreciate all that you've done. Sorry, I'm going to ask our panelists here just to stick around briefly, and I will go ahead and stop the recording.